Today we are going to start with the topic of charging an insulator. In this topic, charging an insulator means, for example, if we consider plastic, wood, and glass, cloth, this type of material, so we know that these materials are insulator. But how these materials can be charged? Because these are insulators, and we know that insulators are not good conductors of heat and electricity. One more thing, it is not compulsory that electrons only exist in the metal. Electrons are also available in insulators, but there is only one difference, that electrons can only vibrate in insulator about their fixed position, whereas the electrons are free to move in conductors, right? So this is the difference. So that's why conductors are good conductor of heat and electricity, but insulators are not good conductor of heat and electricity, because electrons can only vibrate about their fixed position in insulators. But we can charge insulators, charge in the sense that charge will remain on the surface of the insulator, not like it will permanently transfer through the insulator. It will only remain on the surface. Charging an insulator. And there is only one method we have to practice in this chapter, that is called the friction method. So when we rub one object on the other, so definitely that will causes the friction. And because of that friction, we got charge on the body, and that is called the process of charging an insulator with the help of friction. So first of all, a body achieves charge due to the imbalance of number of protons and electrons This is the general idea of getting charge on a body. So when any body gets a charge, so definitely we have unbalanced number of protons and electrons. For example, if we have 10 electrons and we have 8 protons, it means we have more number of electrons, so body got negative charge. But if we have less number of electrons than protons, so that means body got positive charge. So this is the procedure that we used to follow for the charging an insulator. And always remember, just like in the previous topic we discussed, that only electrons are available to move, because protons are in the nucleus. So proton cannot move from their position, only electrons can move. And when electrons can move, so either we have excess of electron on the surface, or either we have deficiency of electron on the surface. So for example, if we used to say, if a body loses electrons, this is one scenario. And the other scenario is, if a body gains electrons. So this is case number two. So in the first case, we know that when body loses electron, so there will be deficiency of electrons on the body. So body becomes positive charge. And in the second case, the other body gains electrons. So there is excess of electrons. It means body gets negative charge. So again, uh, only electrons can move, only electrons are free to move. So that's why we always used to write with the reference of electrons. Never write your answer with the reference of proton. Otherwise, you will get 0 marks for that because there is no concept of the moving protons. So protons cannot be added or removed while charging a body. So this is very important point. Now, for example, if we consider some types of bodies, and let's see how we can get positive charge or negative charge on the body. And one more important thing, we don't need to remember any specific body with a specific charge. We just need to know about the process, that how process takes place. Because in your exam question, they will not ask about like this is the type of the body, like we have a wool cloth. So what type of charge it will get? So they will not ask questions like this. Okay. So we don't need to remember the name of the body with the name of the charge. We only need to remember the process, that how process takes place. So with the help of the process, we can identify easily that what body gets the positive charge and which body gets the negative charge. So for example, we are using the friction method. So procedure is very simple. First of all, if we consider a glass rod, let's suppose, and with the glass rod, we are using a cloth. So in the first diagram, you can see that both are in contact with each other. So when we rub both of them together, so one body gets, let's suppose this will get positive charge. 1, 2, 3, 4. And we have to draw the same number of charge, right? Because if one body gets uh, 4 electrons, so other body loses 4 electron. So number of charges must be equal. So 1, 2, 3, 4. So the cloth gets positive charge. It means electrons transfers from the cloth to the rod, and rod gets negative charge because electrons is actually gained by the rod and loses by the woolen cloth. So this is woolen cloth and this is plastic or glass rod, whatever we want to consider. Now the process is very simple. Let's suppose if they ask you for like 4 marks or 3 marks, that write down the process, how this charging of the body takes place. So the first point is, first of all, friction. Due to friction, Heat is produced because to transfer the charges, we required some amount of energy. So that energy is gained by friction. So this heat is absorbed by electrons. So now electron gets energy from the thermal energy formed of both atoms. Now, basically, when we make contact with the two bodies, so one body, the electrons of one body are loosely bonded, and the electrons of the other body are tightly bonded. So the electrons which are loosely bonded loses their electron, so that body loses their electron, and the other body that have a strongly bond of the electrons, so they starts to gain electron from the other body. So this is the procedure that we have to mention in the answer. So third point is the body which has its electrons weakly bonded to it loses them, and the other body in the contact and the body in contact gains them. So this is the process. So the body which loses electron becomes positively charged. And one more thing, just like we mentioned in the diagram, the number of charges must be equal. So the electron lost by one body are equal to the electrons gained by other. And the last important thing, that insulators only gains charge at the surface. So insulators gain charge at the surface only. So these charge are not like permanent transfer from one body to another. This charge can only be gained on the surface only, right? So it is like a temporary charge. Because in our daily life, what we observe, for example, if we are walking in a room continuously, and in that room there is only a carpet on the ground, and that is like a winter season, because in winter season the movement of the particles are slightly slower as compared to the summer season. So their movement are like slightly freezed. So basically, when we are moving on the carpet or the type carpet type surface, so because of friction, we got thermal energy. So because of friction, when we got thermal energy, so the charges, our body gets charged because of the friction, just like this process. And for example, after walking for some time, when we touch the knob of the door, so that knob is made up of metal. So metal is a conductor. So that conductor attracts, or that conductor gains the charge of our body. They allow to flow the charge through that knob. And when the charges move from our body, so we feel that electric shock, because charges are traveling from our body to that metal knob of the door, right? So this is the process, or the type of electric shocks we got in the different forms. For example, when we are moving on the escalator and we are placing our hand on that rubber support. So because of friction, we got charge, right? And because of that charge, when we suddenly touch any metal surface or any metal conductor, so that charge got discharged from our body and we feel again that electric shock. So all this happens because of this application of electrostatics, right? Any confusion in this?
No.
Right. Okay. Next, we discussed about the transfer of the charges, how charges transfers, and which body gets positive charge, which body gets negative charge. We can identify by the given information, right? For example, in this diagram, the charges are given, but let's suppose in our question there must be some hint given, so we can identify from that hint. Okay, you don't need to remember that this body will get this type of charge. It depends upon the information given in the question. So in this diagram, we observe that this body got positive charge and the other body got negative charge. And for example, if we consider questions related to this concept of the charging of a body, in MCQs, like you will get so many questions related to this idea, and you will get questions in different form also. For example, if you consider those questions, you will get this type of questions mostly in your MCQs, like question number 1. The diagram shows an uncharged ball coated with metallic paint, and the ball is suspended from an insulating thread. It is placed near a positively charged rod. So there is a metallic paint. Metallic paint means we know we are talking about free electrons idea, and then it is suspended from an insulating thread, and now it is placed near a positively charged rod. So which diagram shows the charge distribution on the ball? So we know that negative charge attracts towards the positive charge, right?
It can't be A or B.
Right. And it is mentioned uncharged ball. It is mentioned in the question uncharged ball. So it
Mm.
means that the number of protons are equal to number of electrons. So that's
D.
why
So D?
option.
Yeah.
And also we need to consider there are equal number of protons with equal number of electrons. So that's why option D. Question number 2. A polythene rod is rubbed with a cloth and cloth becomes positively charged. So which statement describes the transfer of charge?
It's A.
Yeah, it's A.
Negative charges are transferred from cloth to polythene. Cloth becomes positively
No,
charged.
it should be D, right? Because like positive charges are what gets transferred.
Yes. So from the cloth, negative charge transferred from the cloth to the rod.
Yeah,
Negative charges are transferred from cloth to the polythene, right? Option A.
so the negative charges are what gets transferred, right?
Positive charge will not get transferred, only negative will transfer, right?
Yeah.
Because cloth gets positive charge, it means it loses its electron. So that's
Mm-hmm.
why other body gets negative charge and this,
Negative.
yes, that's positive charge. And this is also the same type of question. Question number 3, a positively charged rod is brought near to an isolated uncharged conducting sphere. So again, we have a positive rod and it is brought
Uh,
near to an
D.
isolated uncharged conducting sphere.
D.
You will believe me.
It's
Is that
uncharged.
D?
Yes, it is
D.
Yeah.
uncharged means we have both positive and negative charges
Neg-
available
yeah,
on
so
this.
D.
Yes. So negative transfers towards left hand side. So X is negatively and Y is positively charged. Correct. Because sphere is uncharged.
Uncharged. So it
Yes.
has to be.
And this is the same type of question, only they are asking the different idea. A polythene rod becomes charged when rubbed with a dry woolen cloth. So the charge caused is a result of which process?
A.
Yeah, A.
Friction producing a movement of electrons.
Yeah.
Right. Because protons cannot move, there is no idea of magnetism in this electrostatics. And now we have two spheres, a positively charged sphere. Charged insulated metal sphere is brought close to an uncharged insulated
D.
sphere. Option B, okay. So for charge
Yeah,
distribution,
B.
we know that this is positively charged. So overall we have positive and the other one is negative charges. So that will shift
Mm,
the other side.
and it's uncharged, so both positive and negative.
Yes. So option B, correct. Okay, if we talk about the earthing process, right? So let's suppose if we connect a wire with any neutral body or any charged body, right? So for example, in this diagram, you can see we have a sphere. Sphere is uh, placed on an insulated stand, but there is a wire which is connected with the earth that is called earth wire. So this process is called earthing process. And now we place positive rod close to that sphere. In the same way, we can place negative charge close to the sphere. So both possibilities are there. So for example, if we talk about the earthing process, so the process of earthing is very simple. We just connect a wire to transfer charge from that body to the ground. Connecting a charged body with ground is called earthing. So basically, let's suppose if we are using any electronic device, and that electronic device, for example, if we touch that body and we are getting electric shock, like a minor electric shock, so we need to connect earthing wire with that body to ground those charges that are available on
The
that are,
object, right?
yes. So for example, if we are using a computer system, so now in new computer system, we know that we have RGB lights and all that components connected. So there is a chance of getting uh, the charge on the body, and to ground those charges, we used to connect one wire with that the body of the system, and then the other wire to the wall or to the ground or to any other metallic object, so that all the charges transfers from one body to another. So that is the process of earthing. And why it is called earthing process? Because we mostly connect that wire with the earth, because the size of earth, we know that that is massive as compared to the size of any device or any component. And when we connect that wire with the ground or with the earth, so what happens actually, we have very large reservoir of charges in the earth. So that's why if small charges transfers into that ground or into the earth, so that will not affect any change in the earth. So that's why it is called earthing, because earth is a reservoir of charges, as it contains huge amount of protons and electron. So we know that we have so many charges available on the earth. So that's why we can easily connect that earthing wire with the ground, so that a small charge can easily transfer to the earth, and that will affect nobody. So nothing will get any electric shock. And for example, if we consider one body that contains a positive charge, so this is a positive charge, and we connect a wire with the ground. So this is one example. So in this example, body is positively charged. And we know that a positive charge cannot travel or cannot be transferred from one body to another. So this body is positively charged. So according to the logic, this positive charge will not transfer, right? But just like we discussed that Earth is a reservoir of charges. So definitely in Earth or in the Earth reservoir, electrons are also available. Free electrons are available, so those free electrons can be traveled from the earth to the charged body, right? So this is the possibility, because protons cannot be transferred. So it cannot be transferred to the ground. But electrons can be transferred from the earth to the sphere. So we can say that electrons can be transferred from the earth to the sphere. And we can say when a positive charged body is connected to earth, it pulls electrons from it and becomes neutral. So electrons transfer from the earth to the sphere and the sphere becomes neutral. Now, the second possibility is if we got negative charge on the sphere or on the body, so now it is very simple. Electrons are free to move, so definitely electrons travel from this body to the earth side. So when a negative charged body is connected to earth, it pushes electron to ground and becomes neutral. So this is the process that takes place. In the negative charge body and in the positive charge body. And just like we discussed some example, in that examples you observe how the charges can be attract or towards the body or away from the other body because we have charges on the body given. For example, now with the reference of the earthing process, we will discuss. So a positively charged rod is held close to an earthed metal sphere but describes the charge on the metal sphere. So we have positively charged rod close to an earthed metal sphere. So what describes the charge on the metal sphere?
A.
It is negative because electrons are attracted towards the rod, okay? Because in this example, we know that we have positive rod close to it. And because of that positive rod, electrons attract towards that positive rod. And on
Mm.
the other side, we have ground wire connected also. So because of that grounded wire, what happens? That electrons can easily be transferred to the ground. So this is the scenario that we have on one side we have positive rod, so electron can be attracted toward the positive rod, and on the other side we have earthing surface, earthing wire. So with the help of that earthing wire, electrons can easily transfer to the ground. So now in this situation we have four possibilities, and you are saying option A is possible, that it is negative because electrons are attracted towards the rod. Okay. And for example, if we consider B, it is neutral because electrons are attracted towards the rod and protons are repelled. So this is not possible. It is
The idea of protons is wrong.
yes.
So even that's where D is wrong. And then it can't be neutral as well, right? Because if it's neutral, then how is it attracting it?
Yes. It cannot be like neutral because it cannot be completely attracted by the earth because there is positive rod also. So some are also attracted towards it. So B and C, these are not possible. It is positive because protons are repelled by the rod. Again, they are talking about proton. So that's why option A is the right option. It is negative because electrons are attracted towards the rod. Okay, right. Question number 9. Two charged metal spheres are suspended close to each other. Which diagram shows the charge distribution on the spheres and the direction of the forces on the spheres?
See,
C. Okay. These are two charged metal sphere. Okay. And which diagram shows the charge distribution on the spheres, right? And the direction of the forces. Okay. Basically, uh, in option C, we have one positive, one negative. So because of the opposite charge, they must be attract each other, right? So when they attract each other, so their direction must be towards each other. So that is right. But the problem is that the charges are on the other side. For example, if they are attracting each other.
but won't it be like if they're on the other side, then this
Yes.
side will have um
For example,
like
hmm,
won't it be like if there's positive on the outside of C, there'll be negative on the inside of C, and then G's opposite for that?
right. So basically the problem is they have opposite charges, but those charges are on the other side of the sphere. Why not on this side? Okay. Because if
Because
hmm,
we have to we can make out that there's like
hmm.
negative charges on this side and then like the positive charges on this side and then they repel, they attract, right? Because in D it's going the opposite way.
Basically, if we consider C and D, so the direction of attraction is right mentioned in option C, but the distribution of charge is correctly shown in option D, right? So these two options are 50-50 correct, 50-50 not correct, right? Because of the
Mm-hmm.
direction and because of the charge distribution. Like in C, why the charges are not close to each other, why they are away from each other if they are attracting. And in option D, the direction of the forces are opposite. So that must be force of attraction. So it means option C and D, these are not like the correct choices, right? So if we consider option B, so what about option B? Option B is possible or not? Because it shows positive charge and they are repelling each other,
Yeah, it can be B.
right? So B can be like a possible option as compared to C and D. because C and D are doubtful options because of the distribution and the direction of the force. So that's why if we consider option B, so B is the right option because of the force of repulsion and like charges. Okay. So in this chapter, basically we got this type of question sometimes that is confusing because right now we are practicing, so that will be easy for us to discuss. But sometimes when we got like direct unseen question, so sometimes we got confused that how to solve this part. And let's find some more question. This is easy now. Okay. Question number 13. Two charged conducting spheres are placed close to one another. Only is one sphere is positively charged and other is negatively charged, which diagram shows the distribution of charges and the force acting on the spheres.
It's B.
Option B, okay.
Yeah.
So now the distribution is correct. Positive, negative, close to each other, and they are attracting each other. So that is right. Okay, this magnetic screening is not in our new syllabus, and this is also the topic of magnetism. We will discuss over there. Okay, question number 16. A polythene rod is rubbed with a duster, and the duster then attracts small pieces of paper. So are the rod and the duster charged or uncharged? So they rub against each other, and then we place duster close to the pieces of the paper, and the duster attracts the piece of the paper. So what do you think, that both bodies will be charged or will not be charged, or only one body will be charged? So what happens?
Both be charged?
Yes, because when one body is attracting the pieces of the paper, so it means that duster got a charge on itself. So definitely the other body will also get a charge, either positive or negative. It depends upon the scenario, right?
B.
So it will be option A. Both becomes charge. Because according to the information, in the topic we discuss of the charging, that if one body gets negative charge, so it means it gains electron and other body loses electron. So definitely when one body gets charged during friction, so other body definitely gets charged due to friction. Okay. So that's why both body will get charged. Okay. So option A, rod will get charged, duster will get charged too. Okay. Question number 17. A small uncharged metal sphere hangs from an insulating thread. So a negatively charged rod moves close to the sphere. So which diagram shows the charges on the sphere and its final position? So we have a small uncharged metal sphere. So definitely positive will attract towards the negative rod, and negative
A.
will be on the other side. So this rod attracts towards the rod. This metal sphere attracts towards the rod, and it becomes like moves towards the left hand side. So it will be option A. Correct. So option A is the right answer, and you will like get more question in this worksheet also. So you can practice by yourself that what type of question, because in this chapter we have limited information and we got limited type of question also. So this type of question usually asked in your past papers related to the distribution of the charge, transfer of the charge, and the movement of the body. Okay.
Okay.